this whole chapter, this whole section is on quadratics, okay? And basically a quadratic is just a second degree polynomial. And they cover, it's interesting because you do this in Math 65, and then for those of you who are going on to 95, they cover it again. It's almost identical. It's kind of weird how they kind of overlap it like that. I kind of like to rather start out with the graphing part, but the book does that part last and does this solving part first, okay? So a quadratic, again, is just a second degree polynomial, so it looks like this as an example, right? Anything where the degree is 2, these are all second degree polynomials. Okay, so anything like as long as the power is 2, highest power is 2, that's what it is. Those are quadratics, okay? And the reason why we spend time on quadratics as mathematicians is because they make this kind of a shape, okay? If we graph them, this is what we're going to get. And, you know, the arch shape is seen in a lot of different things, particularly in structural engineering. They use this because it's strong, all right? So you'll see it in bridges, okay? You'll see it in, I don't know, the arch, the Arch of Triumph, and some of the other arch shapes that the Greeks did. You know, there was reasons for that. It's also, it's a nice, for some reason they say people are like the shape of an arch, okay? So that's kind of why we spend time with this particular polynomial. So tonight what we're going to do is solve them, and in this chapter they do 8.1 solves them by using a square root technique. All right. 8.2 we skip because the technique that uses is not very good for solving. It's just way long. And this one we use the quadratic formula. Which is by far the best way, okay? So we know how to solve them already because we did it in chapter 6. Chapter 6 at the end. I just graded some of those today. All right, we use the zero product property to solve some of those, but we can use these other techniques because only a certain number of polynomials can be factored. So if you can't factor it and you still need to solve it, then what do? So that's why you have to have these other techniques. So I'm going to go over 8.1 and 8.3, and then we'll probably break. I want to show you some things graphically, and then we'll go from there. All right, so let's take a look at 8.1, which is the square root technique. And this only works for certain quadratics, okay? So let's start out with a real simple, basic situation like that. All right, so we know from last time, now here what we're going to do, or from the last section when we talked about radicals and square roots, that this has to be 3, because 3 squared is equal to 9. But we also talked about how it could be a -3. Remember I said something about a principal square root versus not. So you're going to take this x squared equals 9 basically and square root both sides, and the square root knocks out the square, so we get x equals the square root of 9. But because it works with a positive and a negative, we're going to put this little plus minus here. and then take the square root of 9 and get 3. So the basic idea is that we want to get it so that we have a square on this side and just a plain sort of constant or expression on that side, and then we can square root it and go from there. All right, that's the whole principle or concept idea behind the square root technique. So let's build on it a little bit. Okay, so here we have x squared plus 5 equals 10. All right, again, we want to get this square root square by itself, so we're going to move that 5 over there and get this. Okay, now that I have it in the right form, I'm just going to square root it. Don't forget the plus or minus, and that's it. And we're not interested, I mean, you could take the decimal part of that if you wanted to, or you can just leave it. All right, so this is an exact answer. And if you square rooted it, which is probably like 2.2 or 3, I think, that would be an approximate answer. Yeah, we'll go with this. Okay, so let's say we have one like this. We'll just kind of keep building on it. All right. So remember, we want to try to get this x squared, so we got to get rid of everything else. What should we do first here? Okay, add the 2. What or do we want to subtract 4? Let's subtract the 4. All right. So now we have an x minus 2 quantity squared. So it's in that squared, I don't know what you want to call it, the squared, I can't think of the word for it, but anyway, it's the way we want it. So now we can just go ahead and square root it to get rid of the square. Now what do we do with the 2? Now we're going to add it, okay? All right, so we want to check, and we want to get rid of 4. Yeah, we're gonna subtract the 4, square root, so we get rid of the square, and then add the 2 at the end. So yeah, we're going to simplify this. So this would be 2 plus or minus. What's the square root of 16? 4. So I'm going to go 2 plus 4, that's 6. 2 minus 4, that's negative 2. And there's my 2 answers. Questions on how we did that part? Oh, here's something like this. I didn't see this once. Okay, so let's say we have one like this. What should we do first on this one? Yeah, let's get rid of that 1. And now what? Yeah, divide by 3. And finally, what's our last step? Yeah, square root. Okay. Always remember that there's going to be a plus or minus. Square root of 4 is 2. You're going to have both. Okay. Every time you square root now, it's going to be a plus or minus. Go back to one like this. Okay, so now they have one like this. I'm picking one right out of the book, kind of. Okay, so what would we do in this case? Yeah, we're going to square root right away because it's in that form that we want. Remember, it's plus or minus. And now what? Yeah, let's move that 2 over.
Do you want to take down the 20 at all?
Yeah, we're going to break that down. What are we going to break it down to? 4 and 5. So what does that turn out to be? Right. And that's where we're going to stop. Okay, that gives us the exact answer that we want. Okay? Yeah. So it's very similar to solving equations that you've solved before. It's just you got the square there.
So is there a reason why when we did the square root, or right at the beginning, we did it to the x plus 2, why we didn't do it to the 20 at that one time?
Right here.
Yeah.
Well, so this was not the square root of 20, this was just 20, right?
Say that again?
This was
Yeah,
just
it
20.
was.
It was just 20 in the beginning.
Right, but they both were square root, so I guess it kind of was.
So yeah, so see, we square root this side, square root that side.
Yeah.
Yeah. Let's see, did I give you some from this section from 31 to like 40? Does anybody have their assignment list that knows that? 31 through 40, any of those? No? Okay, good. Okay, any questions on that part? The only time you can really use this, okay, is when, I'm going to go back up to the beginning here. Obviously, when you have x squared equals something, that's pretty straightforward. X squared plus 5 equals a number, we just subtract the 5. X minus 2 quantity squared plus 4, we subtracted the 4, and then we square rooted it. So that form, 3x squared plus 1 works good there. Quantity squared. When it doesn't work is when we have something like this. Okay? Then I can't do anything with, as far as I can't like move 9 over and this over, the 4x over, and then square root it because it's going to be a mess. All right, because I still have this x right here. So that causes a problem. So this is where we have to have a better way. All right, because and these are very common, so we need to have a better way of solving these out. And that's where section 8.3 comes in. So the quadratic formula there's a way to derive it. I mean, we can come up with it, but it's not very exciting to you, so I'm not going to do it. But if you want to see it, I can show you sometime. I'm just going to give you the formula here. So it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so the a, the b, and the c is where these come from. All right. Now the quadratic formula will work to solve any quadratic that you can come up with. So it will even work on these purple ones that we have up here. Okay? It will work. Might take a little while to get it into this form, but it will work. It works on every single one. All right. Last term in the spring, somebody asked me, hey, do we have to memorize that? And I said, you're going to use it so much that you won't have to worry about memorizing it because you'll just know it. It's just one of those things that you just know it. Okay? So let's do a couple of examples of that where we're using the quadratic formula. The main thing on this is that it's always equal to 0. So you have to set the equation equal to 0. All right? Has to be equal to 0. So what I tell everybody is, on a test, so if this is what we're doing, we're solving this, you're going to use a quadratic formula, all right? It's probably a 3-point problem. You get half the points by just doing this part where you go through and you say, a is always in front of the x squared term. So I have x squared, so that means a is going to be 1 because I have 1x squared. B is always in front of the x term, so that would be negative 4. And C is always the constant, in this case negative 10. So it goes A, B, C. All right. Now we're going to use the formula, and I'm going to do it 2 ways for you. I'm going to do it by hand, all right, and then I'm going to do it using Desmos as far as like a calculator device and show you in 2 different ways you can do this. So once I have this, I'm ready to go. I'm going to do it by hand. So I'm going to take the negative 4, okay, and I'm going to put this negative 4 into here. All right, so I got to take the opposite of it. So it's already a negative 4, so the opposite of it's going to be positive. All right, and then what I like to tell people is take the negative 4 or whatever b is and square it in your head. All right, so negative 4 square root of 4 squared is 16. Because it's a negative, so it's going to be positive. Doesn't matter. A is 1, C is negative 10, and A is 1 again. So I'm writing this, all we're doing is substituting these values into that formula, A, B, C, putting them in there, and now I'm going to just work it out. And I'm taking my time here. You can go at whatever number of steps you think you need to take. So I'm going to go 4 times 1 times 10, that's 40. Notice I have a minus and a negative, so that's a plus 40. That's going to be 2. Again, here I'm taking my time. 4 plus or minus square root 56, add that up, divide it by 2, all right, and there's an answer. Now, this is an acceptable answer for me, all right, but it might not be an acceptable answer for if you're taking Math 95, so you should probably break down that 56. If it can be. So let's see. We need a perfect squares that go into 56. I think 4 goes in there. Four goes in there how many times? 14? Yeah. Yeah. Okay, so 4 plus or minus, square root of 4 is 2. That's going to come out to the front. Then I have that 2 on the bottom from right there. And now when I do this, I'm going to divide this part, but not the number underneath the square root. Okay, so this is the same thing. These two are the same thing. Just this one's a simplified answer. This one's just what we got. So that's kind of how you could do it in a step-by-step, write it out sort of way, if that's what you want to do. All right. We could also do it on our calculator. Let's quickly jump into that, and I'll come back to that thing there. Let's see. I can show you on this calculator. I think so. So let's see. We're going to go. I want to see if this works. So parentheses 4 plus square root. Gotta find the darn thing. Square root. Why can't I not find it? Huh. There's square. I guess I could. Oh, thank you. 4. I don't know if it's going to work because it doesn't follow the order of operations very well. 4 plus the square root of 4. That's not even squared. I don't like the way this is doing it. I'd do it in decimals instead. This is way better. Okay, so here I'm going to start with a parenthesis first. All right, I'm going to go 4 plus square root. I'm doing the b squared in my head still. Minus 4. There's always 4 there. Times 1 times negative 10. Okay, divided by. Puts that divided by there. 2 times 1 is 2. Okay, 5.74 is one answer. Then all I got to do is go up here and click, change this to a minus, and negative 1.74 is the other answer. Okay. So I just type it in the decimals just as it is right here, and it will figure it out for us. But it gives us a decimal answer rather than an exact answer. Okay? So be careful with that because there might be some situations where it says give us an exact answer versus an approximate answer. So let's try another one. Okay, Notice it's equal to 0. That's what we want. What's A equal to? B and C. And 20. Okay? A, B, C. Now, it's not always going to be A, B, C in that order. All right? There's going to be some things perhaps mess around. So we have to know that A in front of the x squared, B in front of the x, C is the constant or the number. A, B, C. Okay, so we're ready to go ahead. I'm going to work this out by hand. So I'm going to take the opposite of B, so that's -5 plus or minus B squared. I'm going to square that in my head. Two times A, I'm just going to put 2 there. I can do that in my head also. And now I'm just going to continue to work this out. 4 times 1 times 20. Going to keep going. Now I have 105. Okay, in this case, I'm not sure that I can break down 105 because there's just not a lot of perfect squares that have a 5 in them, right? 25 does, obviously, but I don't know if 25 doesn't go into there. So, I mean, I could try some other ones, but most likely, I don't think we can break 105 down. Okay, let's see, 5 goes in there 21 times. No. So this is done. I can't break the 105 down. I stop. I say, okay, that's it. Let's put a number out in front because we know we've seen some of these. Okay, so what's A equal to? B is 4 and C is 12, right? So here's a quadratic formula. Okay, so the opposite of B, so what would that be in this case? -4 plus or minus. Okay, it's got to square that B, so what would that be? 16 minus 4 times A is 3 and C is, yeah. And here I'm just going to go 2 times 3. All right, do that part in my head. Okay, so let's see. Now we have 4 times 3, 12 times 12 is 144. That's a plus 144. Since we have a minus and a minus. So now I get 160. Again, I don't know. Oh yeah, 160 can be broken down. 16 and 10. Square root of 16 gives us 4. Square root of 10 on the inside. Okay, so again, I can reduce this here and here. Leave the number underneath the square root alone. 2/3, so it's going to be 2. 2/3 again there. Okay, 4/6 is 2/3 this way. 4/6 is 2/3 that way. I need to put a negative out in front. There's an exact answer. Why did I put a 16 there? It's got to be a 10. Get out of there. they're going to have something like this. Okay, so now we have one like this, all right? But what do we have to do first to get it so we can use the quadratic formula? Gotta set it to 0. Okay, easiest thing to do, we just slide the 15 over. Now it's equal to 0, and we can do it. Okay, so you always got to check. I mean, I know you're trying to get through your homework or whatever, or you're busting through them, but there's very often where they'll have an equals there, and you'll write down 15 for C, and then it turns out that it's really negative 15, and everything gets messed up. So always make sure that it's equal to 0. Okay, let's see. I'm going to start with this one, so we're going to go. So what do we write first? Take the opposite of b, so what would that be? 2 plus or minus square root of, what are we going to put inside? 4 minus 4 times 3 times negative 15. And this would be 2 times 3, which is 6. So let's see, we're going to get 4 times 3. Oh, 12 times 15. I might need some help on that one. 12 times 15. 180. 184 over 6. 184's got to be divisible by 4. Might be divisible by what?
It's just 180.
It's just 180? Yeah, and then I got to add the 4. So 184 has got to be divisible by 4. It might be divisible by 16. Anybody try that? See, I don't think it is. No. Let's try 4, see what that does. How many times does 4 go in there? 26? Okay. We're good then. 4, 6, my bad. We're still okay. 46 doesn't break down at all. So we have 2 plus or minus. That baby goes out front. I have this 6. Plus or minus square root of 46 over 3. Okay. Now, if this number, say, was a 5, but this was a 2, we just wouldn't divide at all. You just leave it. Okay, because you're not really helping it by doing the one reduction and then it's not the other, so just leave it. And just to go back to this, so you can see it in decimals again. Always start with a parentheses when you use the quadratic formula here, or else it will mess up. Give you the wrong answer. Oop. 2.59 for the positive one. Click up here, delete the positive, make it negative, negative 1.9. Now, here's kind of a big idea. since I'm in decimals, I'm going to graph the original equation that we had. Not like that. Minus 2x minus 15. Okay, so here's the original equation we have. I type that in. Here's the, I know you can't see it, let me get rid of this. There's our U shape. This is our parabola. That's what this is called graphically. All right. When it's equal to 0, what I'm interested in is these x-intercepts. So there's one answer, negative 1.927 and 2.594. Okay, but remember that is what this is. Okay, 1.97 negative. .59, 2.59. Okay, so the x-intercepts are also giving me the answer. All right. So actually, there's three ways of solving these: square root method, quadratic formula, and graphing. Okay, but the graph's only going to give you that decimal approximation. It won't do the exact answer that's going to pop up here in a second. Okay? It won't do that. I know you're probably getting a little antsy, but here's a problem like you would do probably the square root method on, but you can use the quadratic formula. How much is b in this case? 0. Actually, let's make this 8 negative, or else the whole problem's going to fall apart on us. Since they don't have an x, b is going to be 0. So here we go. So I don't have a negative 0. So there's nothing to write there. Okay. B squared is 0. So I don't have a whole lot to write there. I have 4 times 2 times a negative 8. So that's 64. .64 is a perfect square. There's my answer. Okay, so there is a way to do these on the quadratic formula way rather than the square root technique. Quadratic formula works all the time, square root technique does not. There is one time where the quadratic formula won't work. Is this the one? Okay. Yeah. Okay, so we'll do this one and we'll break here. So we have A, B, C, quadratic formula. We've already used it enough, you probably know what it is. What's B in this case, so what do I write? 6. Plus or minus. Okay, what's going to be inside the square root? So b squared is going to be how much? 36 minus 4 times negative 2 times negative 7. 6 plus or minus square root. Okay, I got 36 here, but 4 times 2 times 7, where all three of them are negative, what are we going to get there? Negative 56, good. Okay, so now I have 36 minus 56, which is a negative 20. So now I have that, okay? But we learned last chapter, you cannot take the square root of a negative number, all right? And this is negative. So we say this has no real solution. No real solution. Because can't take square root of a negative. Alright, can't do that. If I go to graph this, that's what I want to show you. Type in the original equation here, negative 2x squared minus 6x minus 7. Okay, so here's my equation. Notice it doesn't touch the x-axis at all, because it's all down here. Okay, that's why it doesn't have any solution. If I type it in, and right away it says undefined here. I don't even have to divide it by anything. It says undefined, okay, because it can't, again, it can't take square root of a negative, all right? So that's pretty much all there is on the quadratic formula. You just kind of plug the numbers in, turn out. You could do it either way. You can give me an approximate answer in Desmos, or you can go ahead and do an exact answer here, okay, whatever you want to do, which looks more like one that worked out would be like up here, okay. That's completely up to you which way you want to do it. Got to set it equal to 0 though. Questions on the quadratic formula?
Besides taking an arch, what would you use for
Parabolas? So that's what these curves are, right? Okay, so they're structurally sound. Okay, because like I say, you see bridges that way. Those old time arches where they were cement like this, that was part of the reason why they did that. Okay, for some reason arches are appealing. The other thing that I didn't mention, motion. So, like shooting a basketball, throwing a ball, launching, anything like that's going to be usually this type of motion. Okay. I think there was some stuff when they did some things with launching satellites and so forth. They had to get that right trajectory. So. Other good questions? Okay, so what we'll do then is I'll throw a couple problems up there as usual. Go take like a 10-minute break, whatever you want. And then we'll do some problems and we'll go over the supplement and we'll be done and we'll get you back out to the heat. I know you'll be happy about that.